This is about Bindley Corporation. So you can click Bindley tab named Bindley here, and we will use this problem. This is different from previous problem, rental car problem, because this problem is asking the profit maximization as a criterion. So Bindley Corporation has 1-year contract to supply motors for all washing machines produced by Rinso. Rinso manufactures the washers at 4 locations around the country. So New York, Fort Worth, San Diego, and Minneapolis. These are the 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 produced. These are actually the plan for quote for the following numbers of washing machine to be produced at each location. So I believe this will be customer demands. So New York, Fort Worth, San Diego, and Minneapolis. And then Bindley has 3 plants that can produce motors: Boulder, Macon, and Gary. These are the supply capability, supply capacity, or production capacity that Bindley can produce. So due to varying production and transportation costs, the profit Bindley earns on each 1,000 unit depends on where they were produced and where they were shipped. They have to find the optimum solution to here maximize the profit. So where they produce and how much they produce, and then how much they ship, type of thing. And this should be, I believe, total produce. So this matrix indicate that this is per unit, and each 1,000 unit. So shipment will be made in lots of thousand. So that's the $7 per unit. So times 1,000 units, so 7,000. Profit will be made if you ship from Boulder to New York, something like that. So $11,000 to make from Boulder to Fort Worth. So we need to actually, so there are 2 tables here again: candidate solution table and cost calculation table. Here total profit, this is the only different. Otherwise the process will be exactly the same. So put 0. And then the sum, use the sum function. Then we set up profit per unit times the unit to ship. And then final total profit, again we have the sum of all the profit we make. And go to the data and solver, then delete this because it has been created before, so I want to delete. Set objective should be, target cell is the G18 here, and then we we choose the maximum instead of minimum because we want to maximize the profit. And by changing variable cell, we click and select C9 through F12 to F11. Okay, and then we add the 2 constraints again. Our total ship should be equals customer's demands. And then second constraint is our total produced does not exceed current supply capacity or production capacity. Total produced does not exceed or less than equal to current production capacity. And then click OK. And we click the non-negative and simplex linear programming and click solve. And they provide the optimum solution 4242 and click keep the solver solution. Click OK. $4,240,000. That's the total profit they can make based on this optimum solution. Okay. I believe like IPS is the very similar. This is also cost minimization using the Excel solver. So you will do exactly the same. You can create the candidate solution and cost calculation table. And using the Excel solver, you will find the total cost of this amount. And I believe you can do using the Excel solver right now. So let me stop here and hope that you understand how to use the Excel solver to find out transportation method of linear programming, both in cost minimization and profit maximization case. Okay, thank you.